Hello everyone, my name is Deepak Mane and today we are going to discuss one important point of this lesson, matrices. Now in last lecture we studied steps which are used to reduce the given non-singular matrix into identity matrix by elementary row transformation. And today we are going to discuss steps which are used to reduce given non-singular matrix into identity matrix by elementary column transformation. And then we are going to find inverse of given non-singular matrix by elementary column transformation. So let us start. Here one non-singular matrix A is given and we have to reduce this matrix A into I3, that is identity matrix of order 3, by suitable column transformation. And steps which are used to reduce this non-singular matrix into identity matrix by column transformation are as follows. Now in step 1, we have to reduce this element A11 to 1 by using suitable column transformation. Now in step 2, by using this first column, we have to reduce this element A12 and A13 to 0. In step 3, we have to reduce this element A22 to 1. Now in step 4, using the second column, we have to reduce this element A21 and A23 to 0. In step 5, we have to reduce this element A33 to 1. And in last step, step number 6, using this third column, we have to reduce this element A31 and A32 to 0. So let us see some examples. Example number 1. In this example, we have to find inverse of matrix A by elementary column transformation, and the solution is, as here we have to find inverse of this matrix A by elementary column transformation. So we write A inverse into A is equal to I. Now in this product, A inverse into A inverse is prefactor and A is postfactor, and we perform column transformations on postfactor. That means in matrix A, and to maintain this equality we have to perform same column transformations on this matrix I. Now substitute the value of A. Now as A is square matrix of order 3, that means I is identity matrix of order 3, and here by using suitable column transformation we have to reduce this matrix A into identity matrix. So for that, first we reduce this element to 1, then by using this first column we have to reduce these two element to 0, then we reduce this element to 1, then by using this second column we have to reduce these two element to 0, then after that we reduce this element to 1, and then by using this third column we have to reduce these two element to 0. Now here this element is already 1, so that means we have to reduce these two element to 0 by using first column. Now to reduce this element to 0, we multiplying this first column by 3 and subtract it from second column. And to reduce this element to 0, we multiplying first column by 3 and subtract it from third column. That means we performing these two operations. First one, C2 changes to C2 minus 3C1 and C3 changes to C3 minus 3C1. We get this A inverse as it is, this first column as it is, this is second column. We multiplying first column by 3 and subtract it from second column. That means 3 minus 3, 0. 4 minus 3, 1. Again 3 minus 3, 0. Here 0 minus 3, minus 3. 1 minus 0, 1. And 0 minus 0, 0. Similarly, we multiplying this first column by 3 and subtract it from third column. Now this element is already 1. So by using the second column, we have to reduce these two elements to 0, in which this one is already 0. So to reduce this element to 0, we just subtract the second column from first column. That means we have to perform this operation. C1 changes to C1 minus C2. A inverse as it is, second and third column as it is. Now just subtract second column from first column, we get this one. Okay, we are going to perform same column transformation on this right hand side to maintain this equality. Now this element is one, already one. So that means by using this third column, we have to reduce these two elements to 0, in which this one is already 0. Now to reduce this element to 1, we subtract this third column from first. That means we have to perform this operation. C1 changes to C1 minus C3 in this post factor, and in this right hand side we get this one. So this second and third column as it is, just subtract third column from first. So 1 minus 0 1, 0 minus 0 0, again 1 minus 1 0, and here we get 4 minus minus 3, that means 4 plus 3 7. Now minus 1 minus 0 minus 1, and 0 minus 1, that is minus 1. Now this is identity matrix, and this identity matrix is denoted by I, and A inverse into I, product will be A inverse. So this is inverse of given matrix A. Example number 2. So here matrix A and B are given, and we have to find matrix X such that product XA is equal to B, and the solution is XA is equal to B is given. Now just substitute the value of A and B. We get this matrix X as it is. This is matrix A, and this is matrix B. Now when we reduce this matrix A to identity matrix, then it is possible to find X. And for that, we have to use column transformations, because in this product, X is prefactor and A is postfactor, and we perform column transformations on this postfactor. So to reduce this matrix A to identity matrix by using suitable column transformation, first we reduce this element to 1. Then by using this first column, we have to reduce these two elements to 0. Then we have to reduce this element to 1. Then by using the second column, we have to reduce these two elements to 0. Then we have to reduce this element to 1, and after that by using this third column, we have to reduce these two elements to 0. So here this element is already 1. So by using this first column, we reduce this element to 0. So for that, just subtract this first column from this third column. And to maintain this equality, we have to subtract this first column from third column in right hand side. That means we have to perform this operation. C3 changes to C3 minus C1. We get this matrix X as it is, this first column as it is, second column as it is. Now just subtract this first column from third column. So here 1 minus 1, answer will be 0. 3 minus 0, answer will be 3. And again this 1 minus 1, answer will be 0. Now in right hand side, this first column, second column as it is. Now just subtract this first column from third. So 3 minus 2, 1, answer will be 2. 5 minus 1, answer will be 4. And 7 minus 2, answer will be 5. Then we reduce this element to 1. So for that, we perform this operation. C2 changes to minus C2 plus C3. That means minus 2 plus 3, answer will be 1. So we get this one. Okay. Now after that, by using this second column, we have to reduce this element to 0. So for that, we multiplying this second column by 3 and subtract it from third column. That is, we perform this operation. C3 changes to C3 minus 3C2. We get this matrix X as it is, this first column as it is, this second column as it is. Now just multiply this second column by 3 and subtract it from third column. So 0 minus 0, answer will be 0. 3 minus 3, answer will be 0. and 0, this minus minus become plus, 3 to the 6, so 0 plus 6, answer will be 6. Now in right hand side, this first column, second column as it is. Now just multiply this second column by 3 and then subtract it from third column. So 2 minus 0, answer will be 2. Now here 3 3s are 9, so 4 minus 9, answer will be minus 5. And here this minus minus become plus, so 5 plus 3, answer will be 8. Now after that, we have to reduce this element to 1. So for that, we dividing this third column by 6. That means we perform this operation. C3 changes to 1 upon 6 into C3. We get this one. After that, by using this third column, we have to reduce these two elements to 0. Okay. Now to reduce this element to 0, just subtract this third column from first. And to reduce this element to 0, just multiply third column by 2 and add it into second column. That means we have to perform these two operations. C1 changes to C1 minus C3 and C2 changes to C2 plus 2C3. Now this is identity matrix, and this identity matrix is denoted by I. So X into I is equal to this matrix. And as I is identity matrix, so product X into I is X. So we get X is equal to this matrix. Now example number 3. So here we have to find matrix X if AX is equal to B is given, where A, this is matrix A and this is matrix B. So here AX is equal to B is given. Now just substitute the value of A and B. We get this one. Now in this product, A is prefactor and X is postfactor. And to find X by using elementary transformation, we have to reduce this matrix A into identity matrix. And since we have to apply elementary transformations on prefactor, so we are going to use row transformations because we apply row transformations on prefactor. Okay, so by using suitable row transformation, we have to reduce this matrix A into identity matrix, and to maintain this equality, we have to operate same row transformations on this matrix B. So here this element is already 1. So by using this first row, we have to reduce these two elements to 0. Now to reduce this element to 0, just add this first row to second row. That means minus 1 plus 1, answer will be 0. And to reduce this element to 0, just subtracting this first row from third row. That means 1 minus 1, answer will be 0. That means we have to perform these two operations. R2 changes to R2 plus R1 and R3 changes to R3 minus R1. We get this first row as it is. Now just adding this first row to second row. So here minus 1 plus 1, answer will be 0. Here 1 plus 2, answer will be 3. Here 2 plus 3, answer will be 5. This matrix X as it is, this equal to sign as it is, and we have to perform same transformations on this matrix B. So here 2 plus 1, answer will be 3. Now in third row, we have to subtract this first row from third. So here we have to subtract this first row from third. So here 1 minus 1, 0. Here 2 minus 2, answer will be 0. Here 4 minus 3, answer will be 1. And to maintain this equality, we have to perform same operations on this matrix B. So 3 minus 1, answer will be 2. Now after that, this element is already 1. So by using this third row, first we reduce these two elements to 0. Okay. Now to reduce this element to 0, just multiply this third row by 3 and subtract it from first row. And to reduce this element to 0, just multiplying this third row by 5 and subtract it from second row. That means these two operation R1 changes to R1 minus 3R3 and R2 changes to R2 minus 5 as the we get this one. Okay, now we have to reduce this element to 1. So for that, just dividing this second row by 3. That means we have to perform this operation. R2 changes to 1 upon 3 into R2. We get this first row and third row as it is. Now just divide all element placed on second row by 3. So here 0 upon 3 answer will be 0. Here 3 upon 3 answer will be 1. Here 0 upon 3 answer will be 0. And here minus 7 upon 3 answer will be minus 7 upon 3. Now by using the second row we have to reduce this element to 0. So for that we multiplying the second row by 2 and subtract it from first row. That means we perform this operation. R1 changes to R1 minus 2R2. We get here this second row and third row as it is. Now just multiply the second row by 2 and subtract it from first row. So here 1 minus 0 answer will be 1. Here 2 minus 2 answer will be 0. Here 0 minus 0 answer will be 0. And here we multiplying this element by 2 and subtract it from this one. That means this is minus 5 R1, this minus 2 as it is, R2 is minus 7 by 3. Now this minus 5 as it is. Now this minus minus become plus 7 to the 14 by 3. So 3 into minus 5 that is minus 15. Minus 15 plus 14 that is minus 1 by 3. Okay. As this is identity matrix and this identity matrix is denoted by I, and I into X product will be X. So our answer is the matrix X is equal to this one. Now in example number 4, matrix A, B and C are given and we have to find matrix X such that AXB is equal to C. So here AXB is equal to C is given. Okay. So by associative law, this can be written as A into XB is equal to C. So in this product, A is prefactor and XB is post factor. Now just substitute the value of A and C. We get this is matrix A and this is matrix C. And here we have to reduce this matrix A to identity matrix. But here A is prefactor, so we have to perform row transformation. So by using suitable row transformation, we reduce this matrix A into identity matrix. So this element is already 1. So by using this first row, we have to reduce this element to 0. So for that, just subtract this first row from second. That means 1 minus 1, 0. And to maintain this equality, we have to perform same row transformations on this matrix C. So here we are going to perform this operation. R2 changes to R2 minus R1. We get this first row as it is. Now just subtract this first row from second. So 1 minus 1 answer will be 0. Here 2 minus 1 answer will be 1. This matrix XB as it is equal to, now here 31 minus 24 answer will be 7 and here 9 minus 7 answer will be 2. Now by using second row, we have to reduce this element to 0. So for that, just subtract the second row from first row. That means we have to perform this operation. R1 changes to R1 minus R2. We get, now here 1 minus 0, answer will be 1. Again this 1 minus 1, 0. The second row as it is, the matrix XB as it is. Now here 24 minus 7, answer will be 17, and here 7 minus 2, answer will be 5, and the second row as it is. As this is identity matrix and identity matrix into XB, product will be XB and is equal to, this is right hand side. Now here just substitute the value of B. We get this matrix X as it is, this is matrix B, and here we have to reduce this matrix B to identity matrix, and as in this product B is post factor, so we have to use column transformation. That means by using suitable column transformation, we have to reduce this matrix B to identity matrix. So first we reduce this element to 1. So for that, just multiply this second column by 3 and subtract it from first column. That means we have to perform this operation. C1 changes to C1 minus 3C2. We get this matrix X as it is. Now here 3 into 1, 3. So 4 minus 3, answer will be 1. Here 3 minus 3, answer will be 0. Second column as it is. And to maintain this equality, we have to perform same column transformations on this right hand side. So here 5 3s are 15. So 17 minus 15, answer will be 2. Here 3 2s are 6. So 7 minus 6, answer will be 1. And the second column as it is. Now by using this first column, we have to reduce this element to 0. So for that, just subtract this first column from second, that this operation. C2 changes to C2 minus C1. We get this matrix X as it is, this first column as it is. Now this 1 minus 1, 0. Here 1 minus 0, answer will be 1. To maintain this equality, we have to perform same column transformations on this matrix. So here this first column as it is 2 comma 2 1. Now here 5 minus 2, answer will be 3. Here 2 minus 1, answer will be 1. Now this is identity matrix. So I into x, x into I, answer will be x. So this is identity matrix denoted by I, and x into I, product is x. So this is matrix X. So just revise all these points. Okay, practice this example. Thank you.